Okay, so we'll look at a generic electrophilic addition mechanism. If we start off with something simple with a double bond, so we've got carbon, carbon, hydrogen, hydrogen. So we've got here an area of electron density, which is around the double bond. And then we know it's going to be an addition mechanism because we're adding something to it rather than replacing something. Now, you've got your halogen, so we'll use, as this example, chlorine. We know that chlorine is non-polar because chlorine hasn't got any big differences in electronegativity. So chlorine and chlorine shouldn't have this dipole. But when you are bringing the chlorine close to this molecule, because it's coming in towards this area of negativity that we've got here, it actually induces a dipole into the chlorine molecule. So what we find is that we have a slightly positive region this side and a slightly negative region this side. And the reason for that is the chlorine obviously has got 2 electrons in its covalent bond, and here is super electron rich. So if this area here that I am close to is electron rich, it's going to repel and push the electrons further towards this chlorine. So that means this chlorine becomes slightly negative and leaves this chlorine slightly positive. So the reason for it is completely to do with repulsions rather than to do with an actual difference in electronegativity. Okay, so if we go back and have a look at what happens next. So when we've got an area now of electron richness, which we've got around the double bond, and we've got this area of electron deficiency on the chlorine that's delta positive, the electrons move from the double bond to the chlorine. So you see we've got the arrowhead, it's a full arrowhead representing a pair of electrons, and as they come out and attach to the chlorine, that means that the chlorine effectively, if you think about it, the chlorine is attached to this chlorine and it's attached to the carbon at the same time, and that's not stable. So at the same time as the electrons move from the double bond to the first chlorine atom in the molecule, the electrons from within the bond go out onto the second chlorine. Okay, key things here are the direction of the arrow. It comes out from the double bond to the delta plus of the halogen. And then the second one is the arrow comes from the middle of the bond. Okay, so it's literally between the 2 chlorine atoms in the molecule, from the bond and to the delta negative halogen. Now this seems a bit counterintuitive because you might be thinking the electrons are moving from the bond and then they're going to an area of negativity. So why are the negative electrons moving towards the negative? That's the most common misconception, misunderstanding, or difficulty that students have with this. It's not that they are moving there because they're attracted there. They're moving there because they are pushed there. So when we've got the chlorine, the one that's delta positive here, is now attached to the carbon and it's attached to this chlorine at the same time, this chlorine here has got way too much going on around it in terms of electrons. So that means that if it's got electrons from up here, the electrons that we've got present in here are repelled, and they are repelled even further to the point where they move out of the bond completely. Okay, so once we've done that, one second, what we end up with should be a carbon. It's still attached to the 2 hydrogens it was attached to before, the same on the other side. And now we've got a carbon that is attached to a chlorine. And at the same time, we've got a chlorine that came off with both electrons, so it broke by heterolytic fission, meaning that it took both of the electrons from the bond. So I've got this chlorine now, and this carbon up here is missing a bond, so this carbon is positively charged, it's a carbocation. So the next thing that happens is I've got an area of positive, I've got an area of negative. So the last stage will be that the electrons then move from the chlorine and in to that positive carbocation. Once they've done that, then what we end up with is what we had earlier, but now with an additional chlorine. So because we had two chlorines, it was a Cl2, both of the chlorines have attached across the double bond on either side. Now this mechanism, it goes in two stages. So you've got the first stage where you're breaking open the chlorine and you're attaching one of the chlorines to the initial molecule. And then the second stage is when the other chlorine, what's now chlorine ion, is coming back in and attaching to the carbocation. Okay, so that's a breakdown of electrophilic addition mechanisms, and it happens in exactly the same format for anything that you're looking at. So the steps and the stages are always going to be the same.